The question is to find the limit. If we have limit of complex fraction like this, the first thing we have to do is we have to eliminate these denominators. So what we can do is we can multiply by x in the numerator and denominator. Okay? So this is equal to limit as x approaches 1, x times 1 over x, that's 1, x times x, that's x squared, so 1 minus x squared, x times 1 over x, that's 1, x times 1, that's x, so 1 minus x, right? Now if we factor the numerator, that's going to be 1 minus x, 1 plus x, right? Since 1 minus x cancels out, and if we substitute 1 for x, then that's going to be equal to 1 plus 1, which is equal to 2, right? So the answer is 2. For this limit right here, this is also complex fraction, and we have square root of x in our denominator, right? So we're going to multiply by square root of x, both numerator and denominator. Then this is equal to limit as x approaches 1. Square root of x times 1, that's square root of x, and square root of x times 1 over square root of x, that's minus 1, right? Denominator, we just have x minus 1 times square root of x, right? Now if we substitute 1 for x, then that's going to be equal to 0 over 0 in determinant form, right? So we're going to rationalize this expression by multiplying square root of x plus 1 here and in the denominator, right? Then this limit is equal to limit as x approaches 1. We have x minus 1 in our numerator, denominator x minus 1 times the square root of x times square root of x plus 1, right? So this factor x minus 1 cancels out. And if we substitute 1 for x, then that's going to be equal to 1 over square root of 1, 1 plus 1, right? So that's 1/2. So the answer is 1/2, right?